Production funding for QED with Dr. B is provided by
Battelle cares about STEM because it was part of our founding. Gordon Battelle, our founder, believed in building an institute that would actually better society through the use of science and technology. And this year we're going to hit a goal of 1 million students a year that we'll be able to impact around the country.
American Electric Power Foundation, boundless energy for brighter futures. And by viewers like you. Thank you.
I'm Dr. Frederick Bertley, scientist and President and CEO of COSI. Welcome to QED with me, Dr. B. Let's talk about science.
Dr. B, I'm really excited about today's show because we're talking about astronaut training. When you were a kid, did you ever want to be an astronaut?
You know, it's so funny. I grew up being like a little outdoors sporty kid. I wasn't thinking about the typical astronaut thing. But when I became an adult, I realized how cool that is. And I wish I thought about it earlier. It's too late for me, but astronauts are clearly the coolest people down here on Earth.
So when NASA puts out a call for astronaut applications, they get tens of thousands of applications. These are all these highly qualified candidates. Why do you think it's so important for NASA to have so many different experts on board?
You know, it's so interesting. When you're up there, you need to have your engineers and healthcare professionals right there. That crew, that team, that's your unit. And you have to have this breadth of expertise to make sure you can be okay. And as such, they spend a lot of time training astronauts for these missions. For more on that, I spoke with veteran astronaut Thomas Marshburn. I talked to him at the Space Vehicle Mock-Up Facility in the Johnson Space Center in Houston, which houses a replica of the International Space Station. Dr. Marshburn, welcome to QED with Dr. B.
Great to be here.
You've actually had 3 different missions in space, but you spent 2 years training physically, mentally, and scientifically to prepare yourself for spaceflight. Talk to us about that training.
Yeah, well, first of all, it's incredibly exciting when you show up here. It's, for most of us, a lifelong dream to even be here and to be able to work at the Johnson Space Center. We do a lot of classroom work, and then we get into simulators. And then we get into simulators as a group so we can learn to work as a team. It's very, very fast. A few classes straight in the simulator, straight in working with a team. So you gotta learn fast.
Talk a little bit more about that psychological training.
Basically what they want to do is take all these people with different backgrounds and you want to put them in an uncomfortable situation with some risk involved so that they kind of see what their mettle is. And so you can work together as a team. So we're living in igloos, trying to find our food. I lived 40 feet underwater with some of my crewmates for 2 weeks. Places where you have to work together, you have to work hard, be a little uncomfortable, and figure out what you need to work on.
Then you take that very first flight. Talk to us about that.
There is no way in 1G that on Earth to train everything you need to know when you get up there. The fact is, you arrive in space, it's a wonderland. Just trying to be effective at all in 0G is incredibly daunting. It still amazes me we can get as much done as we do when you're floating around and everything else is as well. The view of the Earth is spectacular, so that just stuns everyone when they get up into space. But our motivation is to get the work done. As they say, it's an honor, but it's not a pleasure, necessarily. So we get up there and don't have running water, can't take baths, not the food you necessarily want to eat. It's tough work. So all those things kind of come together to make it a very unique experience, unlike anything else on Earth.
So we're in this incredible space. What do we have in here and what's going on?
So this is the SVMF, the Space Vehicle Mock-Up Facility. We basically have all the habitable parts of the space station, the laboratories, the Russian segment even, here laid out in this building. And it's all life-size. So this is the kind of training we do where we go in, kind of get a feeling for what it's like to live in this confinement so we can learn how to live and work inside the walls of the space station. When I got to the space station the first time, I felt like I was in one of these modules, except I was floating. So this is the habitable volume of the space station. All of the modules that were brought up by the shuttle on the US segment are in a linear direction this way and going back. And The space station flies when it's in space in that direction. That is 17,500 miles an hour most of the time. That's how fast we have to go to stay in orbit. Otherwise, Earth's gravity would pull us down and we'd crash. And over here is one of the main laboratories, and we should step in here.
I'm so excited. I'm going in the International Space Station.
Now, a lot of the space station is a laboratory. Got the Japanese, the European, more US laboratory racks. We call these racks, that's what the wall is, but also the ceiling is a lab rack, and so is the floor. So the entire thing's a laboratory. Every bit of space is used here. So this is just like we were in space, except we'd be floating around. We'd be grabbing onto those handrails, which look exactly like that, in order to stabilize ourselves. On the space station, there's this Red Cross. This is our hospital, everything we need in there. This is one of the robotics workstations. So the manipulator arm is something that we use to grab satellites to resupply the station.
So you control from
We
here.
can control it from
The
here.
arm does outside the space
The
station.
arm is outside the space station, out in the vacuum of space, and we can control it in here. This is where we kind of have our office, if you will. The whole crew gathers around here twice a day, uses the space radio that we have here to talk to the ground, make plans for the day, talk about how the day went. But let's go on in here, because this is probably the most fun and most used module. So we've got the airlock attached over here. We've got node 3 attached over here, which is the gym and the main bathroom.
You guys exercise up in space?
Oh, we have to. We have to. Because we're floating around, our bones would waste away, our muscles would waste away. So we spend 2.5 hours every day. We love this module, though, because this is where we eat dinner. I would usually just hang out right here, had my feet under a handrail, and eat dinner with my buddies. This is what we call the galley, because this is where we can get our hot water and our ambient water to inject it into the dehydrated food that we eat. We like to share food. It's a wonderful way to be together. And typically what you do is you have your can of food, you open it up, and you go, oh, this is good, and just float it in front of your colleague that's next to you. Yeah, so instead of passing it around the table, you just let go of it.
Now you mentioned the airlock, and I know we can't open it, but is this the airlock where you...
That will, if we were to open that hatch, we would be in the next section. You'd see 2 spacesuits there, and we would climb into our spacesuits, go through one more hatch, and then be in the actual airlock, which when we close that hatch, it's just the 2 of you going out on a spacewalk, and you dump all the air out of that one little space, and open the door and go out.
You're part of infinity at that point.
Part of infinity. at that
Wow.
point. That's exactly right.
Talk to us about that first moment. You trained here on Earth at NASA, but now you're actually in ISS and you're going to that space lock zone and you're about to do your first walk.
Incredibly excited again, but also a little frightened. I was already used to the zero-G. It was a few days after I'd been in space. Inside the spacesuit is a real delight. We're able to swim around in this little confined space. The big difference is when we depressurized our chamber. And all these big metal parts were banging around inside this little airlock with us, and then everything got quiet because there was no more air. And that was when I said, all right, now this is serious. We were working in a complete vacuum. Then you open the hatch, and all I can say is thank goodness for the training, because it's stunning to see the Earth. Not only the beauty of the Earth, but you get a definite feeling that it is 250 to 300 miles below you. And your body's saying you're gonna fall, but you just rely on your training. You go outside and you immediately look at your hands and look at your work site. That brings your heart rate down, and that's how you can just go off and get to work. And then you get used to it really fast.
Absolutely incredible. So I want to thank you for being on QED with Dr.
Thank you.
B.
Wow, it was really amazing to see a replica of the International Space Station here on Earth. And what I thought was fascinating is, out of all the exciting things that Dr. Marshburn sees in space, one of his favorite places is the dinner table. So Dr. B, why do you think it's so important for them to have these pieces of normalcy on the ISS?
They're actually doing a lot of work all day, different projects, experiments. And so that dinner table is their one reprieve where they can sit there, break bread amongst colleagues, and actually share some fun camaraderie. So it's a really important part of their day.
The training for space is really important because astronauts will be in space for months on end. So Dr. B, what's the next mission that NASA is training astronauts for?
The one I'm most excited about is the Artemis mission. And so we're going back to the moon, and that's really cool. But there's more. NASA is actually going to create a moon base and study all kinds of properties about the moon in preparation to then take humans from Earth to Mars. And the newest NASA astronauts may be some of those candidates for the Artemis project. So you know I had to talk to a new astronaut recruit. I spoke with Jasmine Mogbelli, a member of the 2017 astronaut class who recently completed her training. Astronaut Mogbelli, such a pleasure to meet you.
Welcome, Dr. B.
Tell me a little bit about your childhood. How did you know or think about becoming an astronaut?
I did a book report when I was in 6th grade on Valentina Tereshkova, the first woman in space, a cosmonaut. From then on, I always wanted to be an astronaut, and I just started looking into it more, begging my parents to send me to space camp, which they eventually did. Eventually got to go see a shuttle launch, and here I am now.
You were selected to be part of the 2017 astronaut class.
Yes.
How many classes of astronauts do they have? Is it an every year thing or do they skip years?
It's just based on when do we need more astronauts. Right now, it's been about every 4 years.
10,000 people applied for the 2017 class?
We did. I think it was over 18,000 people who applied.
Almost 20,000 people. That is incredible. Okay, well, congratulations again on
Thank
making
you.
it. So now you're here, going through astronaut training for about 2 years.
Yes.
What was it like to go through that training?
The main portions we focused on were learning how to do spacewalks right here in the Neutral Buoyancy Lab, learning about the International Space Station and all the systems on board, learning how to fly T-38 jets, learning how to fly the robotic arms, and then learning Russian as well. It's an International Space Station. As an astronaut, your crew, you're responsible for the maintenance, you're responsible for medical, you're responsible for the science. And so you have to learn a little bit of everything, and I think that was what was most surprising to me. So one of the most physical things we do in training is here in the Neutral Buoyancy Lab. When you watch astronauts doing a spacewalk, it looks almost effortless. I thought watching them, oh, this is going to be easy. You're just in a suit, but you're operating like normal. But it's not. Every single thing you do, every time you squeeze your hands, you're doing it against pressure because that suit is pressurized to keep you alive in the vacuum of space. You've got these big gloves on, these bulky gloves, and you're trying to sometimes do these detailed tasks. You're pressurized, so every single motion is challenging and is fatiguing on your forearm. And you walk with your hands instead of your feet, and so everything's a little bit different. In terms of the psychological, that's extremely important, and I think one of the most important things that we really look for when we're selecting astronauts. The missions we're doing now, they're long duration missions, and they're only going to get longer as we start talking about setting up a base camp on the surface of the moon and going on to Mars. And so when you have a crew of a handful of people working together, stuck together for that long, that needs to be effective, needs to handle this extreme environment, it's really important how well you work together as a team. One of the parts of training I actually really loved is we do expeditionary training. We go out and put ourselves in difficult situations. For example, Nemo underwater in an extreme environment, you have to be working together to survive. We do NOLS training, the outdoor leadership school, where your decisions have real consequences. If you choose to go the wrong way or do something you shouldn't, you could end up in a bad situation. And we did at times, but we worked through that together. And so it's putting ourselves in real situations where our decisions have consequences and learning to work together.
Here we are at one of the training facilities for NASA astronauts. So first of all, where are we? What is this? And what happens here?
The Neutral Buoyancy Lab is one of the coolest facilities I think we have for training. There's over 6 million gallons of water. It's 40 feet deep, and there is a life-size mock-up of the International Space Station. So it actually tries to simulate that weightless environment of space. Something we've just recently added here on the other side of the pool is a lunar training environment where we simulate 1/6G moon environment. So that's something we started doing in preparation for our Artemis missions to the lunar surface. Not only for training, but also to test the suits that we're working with, test the tools that we're going to use on the surface.
So how many people does it take to put on this Neutral Buoyancy Lab?
It takes a lot of people. We have safety divers with each astronaut at all times, making sure they're safe and okay. We have utility divers that are bringing the different tools they need to use. They need to make sure it's accurately representing what you're going to see in space. We have technical directors and test coordinators who are giving you the procedures and making sure everything's being done safely. People working your comm systems, people working your temperature control, make sure you're not too hot, too cold. A lot goes into this training here.
I love that you shared that. There are hundreds, if not thousands of occupations that get together to put you all up in space, correct?
Absolutely, absolutely.
How cool is the Artemis project to you? What does it mean?
Nothing was more incredible than what we did during Apollo. It was an amazing feat at a time where we had a lot less technology and the power of computers were a lot less. But what I really like about Artemis is it is not just a single mission or single program and that's it. It is setting us up for future space exploration. It's setting us up to go on further to Mars. And it's setting us up to do that in a way where we're all going. And I think that's something that's really important.
So we're looking forward to Artemis, but in the meantime, you've been selected to be the commander of the NASA SpaceX Crew 7 mission to ISS. That's really cool. What is that mission about, and what will you be doing?
Yeah, so I'll be the commander aboard Crew 7. It'll be a crew of 4 of us on a SpaceX Crew Dragon to the International Space Station, where we'll do a long duration mission, probably on the order of about 6 months, doing science experiments, not just on different materials, but also on our own bodies and how we react to space so that we can prepare ourselves to go on further in the solar system. The International Space Station has had humans on board it for over 20 years now, continuously, and so I think that's incredible. Not only are they conducting the research, but them and the people on the ground are making sure we have the life support systems to keep that environment so humans can live on it. We're maintaining it. That's why we have to train in here. So when something breaks, we can send people outside the space station to fix it. When the toilet breaks, we're the plumbers. When someone gets sick, we're the one that take care of them. So you have to not only do the science, but you have to do everything that goes into creating a living environment in the vacuum of space.
Folks, astronauts are brilliant people. They're traveling in space. They know physics, they know all kinds of aviation, all this cool stuff, but they can also fix your toilet.
Absolutely.
That's really cool.
Wow, I'm so impressed by that neutral buoyancy lab. I mean, NASA really has gone above and beyond to train its astronauts for all sorts of environments in space. And some of those astronauts are going on the Artemis mission. So Dr. B, what are you most excited about the Artemis mission?
First of all, we're putting the first woman and person of color on the moon. Second of all, the Space Launch System, that's the rocket that gets us there. This is the most powerful rocket NASA has ever made. Third, we're actually visiting the South Pole this time. We've never set foot there. Fourth, building that moon base will allow us to further study all aspects of the moon. And 5, this is really all about preparation towards this future mission to Mars. It doesn't get more exciting than this, Diana.
NASA needs a huge team of people to run facilities like the Johnson Space Center.
The majority of these employees are professional engineers and scientists. Scientists like Ares Senior Exploration Scientist, Dr. Cynthia Evans, who is a practicing field scientist. Dr. Evans is responsible for training astronauts before they go into space. And I had the pleasure of speaking with her at the Johnson Space Center. Dr. Evans, so good to meet you.
Oh, it's really nice to meet you too. Oh, and welcome to the Johnson Space Center.
As a geologist and oceanographer, you've done research all around the world, from interesting places like the ocean and the deserts to the Antarctic. Talk to us about the research you've done.
I started off in oceanography studying the crust of the oceans. We would sample the ocean bottom at mid-ocean ridges, at trenches where one plate goes under another plate. So you can say something about the structure of the crust, the composition of the crust, what does that say about planetary evolutions. Here at the Johnson Space Center, I've had the opportunity twice now to go to Antarctica to collect meteorites, which are pieces of the asteroid belt. We actually have meteorites from the moon, and we also have meteorites from Mars, our only samples of Mars so far. And we bring them back here to the Johnson Space Center. We curate them and make them available to the planetary science community to do research to understand something about planetary evolution. So it turns out the kinds of rocks that make up the ocean floor are very similar to the same kinds of rocks that you would find on Mars. Being able to understand how they're the same, how they're different, and ultimately what you're trying to do is think about what the planetary evolution is from the very earliest points of time in the solar system evolution.
Why is it important to train astronauts with some of your skill sets?
When the astronauts go to the moon, they're going to be doing spacewalks. They're going to be in these big space suits that are like little mini spaceships. They're heavy, they're bulky, they're probably not very easy to move around in. They're also going to have a bunch of stuff like hammers and sample bags. Field of view is limited to a certain extent, and they're going to be in really rough terrain. So what we want to do is make sure that they know how to look at a planetary surface with all this stuff on, and kind of build the muscle memory. We teach them, we actually have a little mnemonic for it, it's called Look Odd. We teach them how to look, observe, describe, document, look for patterns, so that when they get on the surface of the moon, they don't have to be thinking about, what do I do first? By the time they go, they will have seen enough territory that's relevant to the planetary landscapes that will be able to do the best science they can, because there are eyes and hands on the surface of the moon.
What excites you about the Artemis project, and what do you hope that these astronauts and you as a researcher finds on this trip?
Oh my gosh, when we went to the moon during Apollo, we really only sampled, I think the area was about 1/6 of the moon's surface. And if you think about the Earth, North America is about 1/6 of the Earth's surface, right? So if you can imagine trying to understand a planet from just sampling North America, you're not going to get there. So we're going to go to the south polar regions of the moon. We'll be collecting different kinds of rocks, maybe rocks from a little bit deeper in the moon's crust, or maybe even the upper mantle. Also, the areas in the south polar region have very dark, we call them permanently shadowed regions or persistently shadowed regions. They're dark, they're cold, they may have frozen volatiles. So that's something brand new, to be able to bring back frozen regolith or frozen ices and bring them back to Earth to study, to say something about the early Earth-Moon system evolution.
How has the training changed over the years? I mean, I'm sure technology is one thing, but what about everything else?
One of the success stories of the Apollo training was the fact that they ended up training with the scientists and the mission flight controllers, like the operations guys, the hardware engineers, the managers. They all went out in the field, and they spent a lot of time in the field, up to 1,000 hours in the field before a single mission. And so they had an integrated team that learned the language of geology and field science. And so we are taking that lesson to heart, trying to continue that. But in the meantime, we have new tools like augmented reality, virtual reality. We can render environments, the lunar surface or other planetary relevant environments in virtual reality, and test out bits and pieces of the operations as well.
What's the thing that excites you most about the Artemis project?
Whenever you go to a new place, you just see stuff that you can't imagine. And I think we all know this, like when we go someplace new, we might pull out our phones and look at Google Maps and think that we have what it's going to look like in our mind's eye, but then we get there and you go, well, that's not exactly what I thought. So we know that's going to happen with the Artemis astronauts. We're going to see stuff that we just didn't quite put together despite the data that we had. But also the fact that they're going to have a chance to, again, go and bring back samples that are unlike any samples that we've ever collected before. And hopefully we'll be able to study them for another 50 years.
What are these?
These are simulated moon rocks for the lunar landscape that we're building on the bottom of the pool. So these things are going to get plunked into the pool, and the astronauts are going to be training in their 1/6 gravity simulation to be able to walk over them, to use them to hammer, to do all kinds of piecemeal training for doing exploration on the moon. And they're big enough so that when you shine a light behind them for a simulated south polar sun, they're going to cast really long shadows. So there'll be a really good environment that simulates the lunar surface.
So that's a lot of things that you share with the astronauts. What's the most important thing you actually train regarding the astronauts?
We teach them so that they can go anywhere and they can orient themselves, they can start looking around, they can start seeing the patterns, seeing what's normal, seeing what sticks out as something not normal, then start describing it in terms with the language that we've been training them on, and documenting it either through photography or verbal descriptions. It's very simple, but there's a lot packed inside of it is probably the most important thing that we do with the astronauts.
You train them to be scientists and explorers all in one.
So yes, exactly,
All right.
exactly.
This is really fantastic. Thank you for sharing this with me.
Oh, you're welcome.
My takeaway from today's show is that it takes an amazing team to train these NASA astronauts. I think space travel wouldn't really be possible without all their expertise. Dr. B, what's your takeaway?
My takeaway is being an astronaut just is not easy. If you're one of the lucky few who gets recruited, you have to go through 2 years of physical, psychological, social, and scientific and engineering training just to be ready to go in space. But it seems totally worthwhile to have that opportunity to go into space and to boldly go where few have gone before. And that's QED with Dr. B. That's me. Join us on Facebook, Instagram, and Twitter, and we'll see you next time.
Production funding for QED with Dr. B is provided by
Battelle cares about STEM because it was part of our founding. Gordon Battelle, our founder, believed in building an institute that would actually better society through the use of science and technology. And this year we're going to hit a goal of 1 million students a year that we'll be able to impact around the country.
American Electric Power Foundation, boundless energy for brighter futures. And by viewers like you. Thank you.